Hello, this is Yelin, and I will explain the homework 10, problem 1 and 2. And this problem is we need to collect the definition and the simple properties of this stochastic process. So the first one is a Poisson process. Poisson process is defined as x of 0 equals to 0 and x of t1 minus x of t2 equals the number of things happened in t2 to t1 with the probability, and the probability of x of t1 minus x of t2 equals to k equals e to the lambda times t1 minus t2 times lambda times t1 minus t2 to k divided by k permutation. So this is a Poisson distribution form, and Poisson process tells us in the certain time interval the things happens how many times the things will happen. So it has the property like when TA greater than TB, greater than TC, and greater than TD, their non-overlapping intervals are independent. So that means this probability equation, and is the probability mass function, and with the mean equals to lambda times t, and autocorrelation function is lambda square times t1 t2 plus lambda mean of t1 t2. So that makes sense because we know that the longer we wait and the longer we wait, the things will happen in the things will happen times will be larger. And the second is Poisson increment. Poisson increment, by definition, we know that x of t is a Poisson process. Then y equals to x of t plus epsilon minus x of t divided by epsilon. This stochastic process is a Poisson increment process. So the mass function is this. We divide this from the above. See that? And the mean equals to lambda, and the correlation function in these two different interval have two different form, but we could see it's a WSS because the Poisson increment means in a certain time interval we know that is epsilon, and the things happens how many times the things happens, so it tends to be a certain value, the mean of this process. The third is Poisson impulse. I don't know how to derive its mass function or something, so we define it. Y of t is a Poisson increment. Then Zeta is a Poisson impulse response when epsilon tends to 0, its limit. So from above we know that it's a the mean is equals to lambda. The mean equals to lambda. The autocorrelation function is lambda square plus lambda times delta of t1 minus t2. So it's I think it's also WSS, and this function could also be seen as this. Sorry. Third is semi-random telegraph signal. Is the definition. K is even in interval t 0 to t, and it's equals to 1. And K is odd in this interval is equals to -1. And K is a random variable. It's it follows the Poisson distribution. So the mass function, we could derive it, and it's in this form. And mean function is equals to e to the -2 times -2 lambda t, and the autocorrelation function equals to e to the -2 lambda, absolute value of t1 minus t2. And the fifth is a random telegraph signal. By definition, we could use a as a random variable which has equal probability at 1 and -1, and xt is a random process. It's a semi-random telegraph signal, and a and x of t are independent. So the mass function, we could derive it, because we know that if yt equals to 1, it has to be xt equals to 1 and a equals to 1, and the probability of xt equals to -1, a equals to -1. So from this we derive this, and it's equals to half. Similar, we also derive the y equals to -1, so it's also equals to a half. And we also know that the mean is 0. Autocorrelation function is e to the -2 times lambda times t1 minus t2 absolute value. So we know it's a WWS. And 6 is a random walk. Random walk, we define it from we could just think it as a we could just derive it. We could just define it like this: the number of things happen, and it equals to the number of s happen, which has the value plus s, and the number of things not happen is minus s. So we could derive the probability density function, mass function. When use the binomial distribution form, we derive it like this. And from the probability density function, mass function, we know that the mean equals to 0. Autocorrelation function is mean of n and m times s square, where t1 equals to nt and t2 equals to mt. Last one is winner process. Winner process. We derive define winner process from the random walk when the value tends to 0 and t tends to 0 and tends to infinity. And the density function, we could do some approximation. We know that the binomial distribution density mass function and is approximately equals to a Gauss function when n tends to infinity. And we also derive it as derive the mean function. The mean function equals to 0, and autocorrelation function equals to mean t1 t2 times s squared divided by t. So this is the first question. And the second question is we need to collect the definition and properties of this stochastic process. The first one is WSS. WSS means the mean function is a constant, so it's the mean function will not change when the time change, and the autocorrelation function is only a function of the time difference. So this is a WSS. And independent increment process, which means the process which the interval of this, the independent interval, means they are not overlapping, and they have the independent they're independent. So the first one times the second one equals to this, and thus that could also we could also know that the expected value of this equals to these two multiply these two, this product. And the Markov process tells us a process we could if we want to predict the probability of something happens in future, we only need to know the probability that those things happen right now. So it will have no they have no relation to the things happen before. The normal process. The normal process is that a process happens on different time. They're all joint normal function for any n and any t. So we could know the PDF of this normal process will be in this form. And strictest and stationary process. The stationary sense process will have no change for any n, any t, and any epsilon to their probability density function. So their stochastic will not change if this change. The white noise. The white noise is have the properties like the mean equals to 0 and autocorrelation function is only a single pulse. at when t1 equals to 2t2. The mean ergodic process is have this property. It means the mean equals to the expected value. The mean of this process in the whole time from the minus infinity to infinity, it equals to the expected value. And that's it. Thank you.